Hello and welcome to our presentation on credit card fraud detection methods. We will start off by introducing ourselves.
Hi everybody, my name is Valentina. I'm a mathematics and business double major and I'm a sophomore.
My name is Hayley. I'm a mathematics and history double major and I'm a senior.
My name is Chloe. I'm a mathematics and biology double major and I'm a sophomore.
My name is Abbigale. I'm a chemistry major and I'm a freshman. So the problem we were faced with is since the number of fraudulent transactions continue to rise, a great deal of money is lost every day due to credit card fraud. To mitigate the risk, companies seek to find new and innovative ways to predict which credit card transactions are fraudulent. The featured graph shows the significant increase in the number of credit card fraud reports in the U.S. from 2014 to 2018. Our goal is to find new ways to detect fraud and compare various methods so we can make the best recommendation to Bank of America. On the next slide, we have our results. After improving our random forest and k-nearest neighbors programs on Python and Orange 3, we found out that the random forest algorithm provided us with better predictions and results than the k-nearest neighbors. We also found out that some variables were better at predicting fraud than others, and these were total and field 5. We primarily used Orange 3 for data visualization since it is not as applicable to Bank of America's current programs and software. On the next slide, we have our approach. First, we researched our partner Bank of America, specifically focusing on general information and credit card fraud. After this, we focused our research on several methods and techniques we could use, such as random forest and k-nearest neighbors. We then took these techniques and implemented them in several Python and Orange 3 programs. Over the next few weeks, we improved and updated our programs. Following that, we compared the final outputs and scores and overall performance of the programs. Finally, we made conclusions on which method was preferred and came up with our final recommendations. On the next slide, we have some of our research on Bank of America. We found that Bank of America serves 66 million clients in more than 35 countries, while being dedicated to responsible growth. When handling credit card fraud, Bank of America constantly monitors clients' accounts for suspicious activity so they can alert their clients as soon as fraud is suspected. Clients can also report fraud to them if they suspect fraud has occurred. On the next slide, we have our two main data sets that we use for our research. The first one is CC Data Mining 1, and it has 20 variables and 65,534 samples. The second one is CC Data Mining 2. It also has 20 variables, but it contains 100,000 samples. On the right is a screenshot of CC Data Mining 1 in the number software of Mac that displays how unbalanced the data sets are in the sense that there are way more non-fraudulent transactions in them than fraudulent transactions.
As Abigail mentioned, we have been working with Bank of America to help to better their credit card fraud detection methods, and by doing this, we have created several programs. We have primarily worked with two different softwares. The first is the Orange 3 software. This software is not currently used within Bank of America, but is extremely helpful for its ability to do unique data visualization and data analysis, and for its user-friendly software. We're also looking into Jupyter Notebooks. This is already integrated within Bank of America and allows an IPython kernel to run through various code cells. This allows for easy editing and communication between those coding. On the next slide, we have our first program that we created for method testing within Orange 3. As you can see on the right side, here is the workflow for this program. It starts off by inputting data from CC Data Mining 1. It then selects the target variable as fraud and uses a test and score module to try 3 different methods. This includes the tree method, random forest, and k-nearest neighbors. Finally, it gives results and illustrates predictions. On the next slide, you can see some of these results. We use the root mean squared error as a method of comparison between the different methods. As you can see, on the right is actually our results for the root mean squared error, and random forest provided the least amount of error, where the tree provided the most, with k-nearest neighbors falling in the middle. On the next slide, you can see how we tried various numbers of trees within our random forest in order to try and improve those results. This allowed us to guide our following programs and choose the correct number of trees to use. Of course, as we added more trees, it actually increased the runtime and the amount of space needed to run this program. Therefore, we are leaving it up to Bank of America to run a cost-benefit analysis as to how they would like to increase their accuracy while also looking out for that specific runtime. On the right, you can also see one of the incredible visualizations that Orange 3 is able to make. This is actually a single tree that was included within the random forest program. And it shows you how the tree breaks up the different decisions into nodes. And this could be extremely helpful whenever Bank of America is communicating with either clients or others that they are researching with in order to explain how something like a random forest might work. And on the next slide, Valentina will share about the random forest program in Python.
So random forest consists of a bunch of decision trees that are going to perform votes and are going to come up with a final precision. We built this program using Pandas, scikit-learn random forest classifier library, and imbalanced learn mode on Jupyter notebooks. So this program manages to provide features comparison. It splits the data into training and testing sets. It uses mode to deal with imbalanced data, as you can see in the graph on the right. It trains the model, and finally, it tests for predictions. On our next slide, we have our random forest results. So our algorithm provides the recall, precision, and F1 scores. And as you can see on the right, the number 1 row represents fraud, and the 0 row represents not fraud. And for our CC data mining 2, we got a slightly better F1 score than the one for CC data mining 1. That is 54% for CC data mining 2 and 45% for CC data mining 1. Our recall score was also better for CC data mining 2, but precision was the same for both data sets with a percentage of 73%. On our next slide, we have our features comparison. So random forest program also created these kernel graphs that compare fraud and not fraud behaviors for each of the variables. And we think this is important in order to determine how good of an indicator each variable is. So for our CC data mining 1 dataset, we found out that field 3 and field 4 were not good indicators, since their fraud and not fraud curves were kind of similar. But for variables like total and field 5, the curves were more different, so we believe they may be better indicators. On the following slide, Hayley is going to talk about the k-nearest neighbors method.
So as Valentina mentioned, I'm going to be discussing k-nearest neighbors. K-nearest neighbors is essentially an algorithm that you can use to classify data points in a set. It's a non-parametric method for classification and regression that classifies data points by comparing the data point to data points close to it in the data set, which is demonstrated by the graphic on the right, based on the k number of nearest neighbors, which is why it's called k-nearest neighbors. The advantages of this algorithm are that it has a pretty strong consistency rate and it's relatively simple to implement, which means that creating a program is relatively fast. However, the disadvantage is that the program slows as it runs as the size of the data set increases, which means if you're running a lot of data, the program might be slower to run, which means there's sort of a cost-benefit analysis you'd have to run, whether you want to get something running faster or if you want something that will run faster once you implement it. So we implemented a k-nearest neighbors program in Python. It's relatively similar to our random forest program in that it's built using scikit-learn, this time using the k-neighbors classifier library. And it does many of the same things as the random forest program. It splits the data, trains the model, and determines a score for non-fraud and fraud predictions, as well as providing us with calculations for precision, recall, and the F1 score. We also have 2 different versions of this program for CC data mining 1 and CC data mining 2. On the right, we have a classification report for CC data mining 2. You can actually see that from the F1 score, we only had an accuracy of about 47% for predicting fraud, which is a little worse than the random forest library, which had about 53, as shown in the previous slide. So we found that the k-nearest neighbors, although it has a pretty good accuracy, is a little worse for predicting fraud than our random forest program. In addition to these calculations, the k-nearest neighbors program also provides an analysis of the error rate between different values of k. We compared values of k from 1 to 40 to see which would produce the least amount of error, and found that k equal 4, 8, and 14 produce the lowest error rates. As a result, we recommend using a value of k equal to 4 when running this program, as not only will it provide the lowest overall error, it will also run the fastest since it's the lowest value. To recap our project, credit card fraud is an issue that causes companies to lose a significant amount of money every day, especially as the number of fraudulent transactions continues to rise. To mitigate this risk, companies seek new and innovative methods for predicting fraudulent credit card transactions. The goal of our project was to compare several methods for predicting credit card fraud and to provide suggestions to improve the detection process. Overall, we determined that the random forest method outperformed k-nearest neighbors using both Python and Orange 3 software. As demonstrated by the graph on the right, the only area where k-nearest neighbors outperformed the random forest method in Python was precision. However, this value doesn't provide us with nearly as much useful information as the recall score and the F1 score, which the random forest method outperformed k-nearest neighbors in both cases. Given our limited time frame, there were several tasks we were not able to solve, which Valentina will discuss in our suggested future work on the next slide.
So we suggest Bank of America to try other datasets within existing programs to determine time and recall balance for random forest programs, and finally to consider implementing Orange 3 and small programs within Bank of America. On our following slide, we have our acknowledgements. So this project is part of the PIC Math program, and we want to thank the Mathematical Association of America, the National Science Foundation, and the National Security Agency, as well as our faculty advisor, Jessica Sorrells, industry partner organization, Bank of America, and industry liaison, Carrie Gates. On our next slide, we have our references. Thank you very much.